Alright, so this is a simple distillation setup. So we have here our round bottom flask, and that'll hold our mixture. And then we have here the thermometer, which is set inside of here. One thing that's really important is to make sure that when the thermometer is sitting inside, you have to make sure that this part of the thermometer is crossing the section that is on the bottom part of the condenser. And then you know that your thermometer is in the right place to take accurate measurements. So we have here the condenser. Water will flow through it. Just a trickle is all you need. It'll work to cool the liquid that's traveling inside so that it condenses. It always flows from the bottom part to the top part, so water will flow through the tubes this way, in and out. Then we have here our lab jack, and this will contain the container, the beaker for the slop bucket or the Erlenmeyer flask, depending on what we're collecting. We have here the Bunsen burner, and we try to make sure that when we're heating the liquid that it's not too close to it, because we don't want to overheat it or heat it too fast. We want to have it nice and slow. So we have in this video, we have a mixture here of pentane and also ethyl acetate. So we should be able to separate these by simple distillation, because according to the CRC online, the boiling point of ethyl acetate is 77.1 degrees Celsius, whereas the boiling point of pentane is 36.06 degrees Celsius. So since they're more than 30 degrees apart, their boiling point, it should be able to separate these by simple distillation. So what we do first is we, of course, put our mixture into here, into the round bottom flask, and then we slowly start to heat this thing up. We start to heat this mixture up. And so we're going to keep watching this thermometer as that goes on, as this process goes on of this heating up. And once we reach around the certain boiling point of pentane, because that'll be the thing that we distill first, because that's the lower boiling point, we'll start to see liquid trickling down here. So we have here first our slop bucket. It's important to have the slop bucket first so we can get rid of any impurities, if there are any impurities. So we wait for the first few drops of the liquid to come out, but we also have to make sure that the temperature is stable. So like if it's not changing a lot, if it's stable, we wait until the first couple drops go away, and then we switch out the slop bucket for the Erlenmeyer flask. And then we put it there until we completely distill the pentane. So we'll know when the pentane is all distilled, because we know that the literature value of pentane is about 36.06 degrees Celsius according to the CRC. So once we start to get to about, 37, 38 degrees Celsius, maybe we could even wait till 40, then we can switch out the Erlenmeyer flasks for a different one. And then at that point we can wait for the rest of the, because all that's going to distill at that point is the ethyl acetate. And so we'll also know when the ethyl acetate is completely distilled. As soon as the boiling point goes, past 77.1 degrees Celsius, maybe we want to go a few degrees over just to make sure, for insurance, to make sure it's all distilled. It's okay to do that. And so, yeah. So one thing that's also important is the atmospheric pressure. So the boiling point is defined as the vapor pressure of a liquid, or the vapor pressure of a substance. When that's equal to the atmospheric pressure, then that's when the boiling point is reached. So the atmospheric pressure is important because depending on the atmospheric pressure, the boiling point can be different in different environments. It's also important to note that it needs to be uncorrected, because usually atmospheric pressures are given in, they're corrected to sea level, so we have to uncorrect it to make sure we're getting the correct approximation of the atmospheric pressure. Alright, and so after you're done, like after you have your Erlenmeyer flask of your ethyl acetate and of your pentane, One way that you can test their purity is to do IR spectroscopy. You can do that, and then you can observe their peaks, and you can see if they have some of the the groups with corresponding to the peaks that you would expect, and if they do, then it's likely that they're probably pure. Probably an even better way to test its purity is to do the gas spectrometry. The gas spectrometry. Chromatography. The gas chromatography. You can use that, and you can estimate with the peaks. So here's the chromatography. If you have the solvent, which would really big peak, and then you have your solute with a little peak, then that's an indication that the solvent is a pretty pure substance compared to this, and that's another way that you can test its purity.